welcome back. Video number 2. This is the mini lesson, and after this is where you'll get to go into Google Classroom and submit the assignment. I already saw Jordan sneaking in there. Good job, Jordan. Thanks for taking charge of your learning. So to get us started today, let's think about our big idea, or our purpose of learning all of this is that what are some ways that mathematicians can represent parts of a whole number? And then why are the numerator and denominator so important in helping us to explain our understanding of how we can represent parts of a whole number? So let's come on over. You're going to join me for the mini lesson. Here is our guiding question for today. You'll notice it looks just like yesterday. We're going to do the same thing but get a little bit more practice now that I've figured out the kind of video timing thing. Okay, so guiding question, read it with me at home. How do mathematicians use area models and linear models, or number lines, to show how two fractions are equivalent? So the math language we need today is the numerator and the denominator. Remember, this is how many parts are being counted, and this is how many parts are in the whole. We've talked about equivalent, meaning that they are equal or have the same value. We've talked about an area model. This is an example, but another example that we could use is also the rectangle. We've definitely used circles, but rectangles work too. So make a rectangle, cut it into 2 parts, and only shade one of those parts. That's another area model that you can use. And then the number line is another way that we can show parts of a whole, because our benchmark numbers are 0 and 1. That's already telling us that we're thinking about this space in between, or if you take that whole and break it into smaller parts. So keep this in mind. As we're learning and thinking back to our big idea, we're going to be able to represent parts of a whole and be able today to compare those fractions and how the numerator and denominator can help us with that. So let's put this aside. And we're going to start with our first question of how many 1/4 are in 6/8? How many 1/4 are in 6/8? So remember, our guiding question is that we can use area models and linear models or number lines to help us decide if fractions are equivalent. So since I'm comparing 1/4 to 6/8, I'm going to start by drawing that circle first. And so actually maybe this time for an area model I'll do a rectangle. All right. And then I'm going to break it into 8 parts. So first I'll cut that in half, and then I'll cut those halves in half. Now I have 4. And if I cut those halves in half, now I have 8 equal parts. And my numerator is telling me to count 6 of them. 1, 2, 3, 4, 5, 6. There's 6/8. I can also represent that on a number line. Again, my benchmark number is 0 and 1. Okay, and I want to cut it into 8 equal parts. So I'm going to start in half. And then I'm going to cut those halves in half. And then I'm going to cut those halves in half. Okay, and then I can label my number line. So this is 0/8. This would be 1/8. Count with me. 2/8. 3/8. Kayla, count with me too. 4/8. 5/8. 6/8. 7/8. And 8/8, which is equal to 1 whole. And we're representing 6/8, so I'm going to put a dot right there. Now we're trying to decide is how many 4ths are in 6/8. So what we talked about yesterday is that we have to draw 2 exactly precise models so that we can talk about equivalent fractions. If our models aren't the same size, then we aren't able to see if they're equivalent or not, because they're not talking about the same parts. So how many 4ths are in 6/8? So now I'm going to cut this one into 4. So here's half, and then those halves get cut in half, and now I have 4 equal parts. I'm trying to decide how many of these 1/4 will be equivalent to 6/8. So I can see, look, okay, here's a 1/4, there's 2/4, there's 3/4. This and this take up the exact same amount of space. So this is 3/4 is equivalent to 6/8. I know because they take up the same amount of space. This denominator is saying 8 equal parts, 6 are counted, is the same as 4 equal parts with 3 of them being counted. I can also show it on a number line, and I have to turn it toward me so that I can be super precise. My 0 has to be in the same spot, 0/4 this time, and my 1 has to be in the same spot. And then I'm going to cut that in half. Now I have 2 equal parts, cut that in half. Now I have 4 equal parts. So this is 0/4, 1/4, 2/4, 3/4, and 4/4. And you can see that the fraction that's equivalent to 6/8, or that come to the same place on the number line, is 3/4. So there's 2 ways to prove my thinking. All right, I'm going to put another one on the board, and then you're going to pause the video so that you can do your thinking alone or with a family member, and then unpause it to see if your thinking and my thinking are the same. All right, so here's your question. And you can, again, rewind it if you need to see this again. You don't get to rewind in class. You get to rewind here. That's pretty cool. Use that. How many 1/3 are in 2/6? Pause the video. Do your thinking. Okay, here we are. We're back again. Thank you for pausing the video so that you could do your own thinking. So just like we did on the other one, I'm going to start with this one because I'm comparing how many of these are in here. So maybe this time I want to do an area model of a circle. Sure. But both of my circles have to be exactly the same size, don't they? And then first I'm going to represent 2/6. So I'm going to first cut it into 3 equal parts. And it just kind of looks like a peace sign. And then to make 6, I'm going to cut each of those equal parts into halves. And now you can see I have 6 equal parts. And here we're representing 2/6. So I'm counting 2 of the 6. How many 1/3 are going to be in 2/6? Well, in order to figure that out, I have to draw a model showing 1/3. Here we go. There's my 3 equal parts. It kind of looks like a peace sign. And if I were to shade in one of those, as this numerator states, I'm done. Now I don't need to shade anymore because I can see that just one of these takes up the same amount of space or is the same size as 1/3. They are equivalent to each other. They have the same fractional size. You can also prove it on a number line. I'm going to make a 0 and a 1 as my benchmark numbers. Here, the first one, I'm going to cut it into 6 parts. So first I have to do about 3 equal parts. Looks pretty close. And then I'm going to cut those in half, and now I have 6 equal parts. 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, or 6/6, which is 1 whole. We already know. This is showing 2/6, so I got to show where 2/6 is on the number line. Now we can use it again to show that 1/3. It only takes one of the 1/3 to equal 2/6. I'm going to draw the same exact size number line. That way I can show whether or not they're equivalent because they take up the same amount of space, or in this case they're the exact same length on the number line. 0 and 1. Now I'm going to cut it into thirds. 1, 2 lines for thirds. This is 0/3. This is 1/3, 2/3, and 3/3. I have 3 equal parts. So how many times do I have to jump on the number line to be equivalent to 2/6? And you can see just 1. 2/6 is equal to 1/3. Did you get that? Were the models supportive? I hope so. How are we on time, Miss Kayla?
9 minutes
9
and 30
minutes.
seconds.
Oh boy. We're gonna do another one. How many 1/4 are in 2/8? Pause the video. Do some thinking. Okay, are you ready? Here we go. So, 1/4. I'm going to start with 2/8. I'm not going to draw the number line this time again, just because we're getting close on time. So my 2 circles have to be the exact same size. I'm going to draw 2/8 first. So I'm going to cut those into 4 equal pieces, And then I can cut each of those in half, and I will get 8 equal pieces. And this is saying to shade in 2 of them, or I'm counting 2. So 2/8. And now I can see how many of these 1/4 pieces will it take to have an equivalent of 2/8. So my denominator is 4. And so now I'm going to shade in 1 and see if that matches. And indeed it does. It takes 1/4 to equal 2/8. Do you agree? Do you disagree? Why? I hope you agree, because our visual model shows us they take up the exact same amount of space. They are the same fractional part. Okay, one more question. This is taking our thinking to a different level. Which fraction is bigger? Now you're going to use visual models to compare two fractions. It's the same thinking, we're just doing a different task. Which fraction is bigger, 5/8 or 1/3? See if you can draw an area model or a number line to decide which one is bigger. All right, pause it, do your own thinking, and then tune back in. All right, here we go. This will be our last one for today. So which one is bigger? I'm thinking I can draw visual models, but I'm also starting to understand that the size of this denominator and the amount of pieces being counted could tell me how close it is or how far away it is from the number 1. This is already past half. I know 4/8 would be exactly in the middle of that number line, and this is a little bit past half. Okay, it's getting closer to that whole total of 8. This is only 1/3, so if I had a number line cut into 3 parts, this is only one jump on that number line. So I'm already starting to think that 5/8 is bigger than 1/3 because of what I understand about the numerator and the denominator. But we can also draw a model to help prove our thinking. So I'm going to draw a rectangle model this time. Doesn't matter which model, as long as they're precise and they're exactly the same size. I'm going to cut this into 8 parts. So first I'll cut it in half, cut those halves in half, and then cut those halves in half. Look at all that halving. Okay, and it's telling me to count 5 of them. 1, 2, 3, 4, 5. This is showing 5/8. Now we're going to compare it to 1/3. Again, that model has to be the exact same size or it won't work at all. Hello, Suki. Come on up. Are you going to come say hi? She wants snacks. All right. I'm going to now cut it into 3 equal parts, being about as precise as I can. There's 3 equal parts, and I'm only shading one of them. It turns out I was right. 5/8 is greater than 1/3, and I can write that as an equation. 5/8 is greater than 1/3. I was right in thinking about, gosh, this is a lot of parts already being counted out of 8, and this is only 1 part being counted out of 3. I'm thinking it's bigger, and it was right, and I used an area model to help prove my thinking. So now you can go into Google Classroom and work on that assignment that I created for you today for Wednesday, March 18th. Thanks for joining me. I hope you're having fun. I miss you so much. I love you. Keep working hard. And great things are in store for you and your amazing math brain. Thanks, friends. See you tomorrow.